Okay, so the final section for this unit of solving quadratics is bringing it all together and doing word problems. So 6.5, solving problems using quadratics, we now need to remember that we have three different methods to choose to solve a quadratic problem. We can solve from factored form, where we set the factors equal to 0 and find the two roots, quote unquote. We can go from vertex form and use SAM-DEB. Or the third and final step is from standard form, we can use the quadratic formula. So I have three examples for you. We're going to use the three different formats for solving, and so that you have an example for each. So the first example, example 1, a professional basketball team plays in an arena that holds 20,000 spectators. Average attendance at each game has been 14,000. The average ticket price is $75. Market research shows that for every $5 reduction in ticket price, attendance increases by 800. So find the price that will maximize the revenue. So what we first have to do is we have to think about this question, and we see the 20,000 doesn't really have part of our equation. We just know that that's the maximum number that we could hold, but that may not be the maximum revenue. So we want to set up an equation for what our revenue would be, the price of the ticket times the number of tickets sold. And then we can go about looking for a maximum revenue. So remember, when we're looking to maximize something, we're looking for the vertex. So let's see what form we go into. So I want you to try doing the question as far as you can before you press play to check your work. So go ahead and pause the video and then come back to check how you've done. Alright, so hopefully you set up the equation as the price times the attendance, so $75 minus $5 reductions, 5x, and 14,000 plus 800x, where x, okay, where x is going to be your number of changes. Okay, so let x equal the number of changes. Okay, so that could be positive or negative. So because we're in vertex form, we can go straight to setting our roots equal to 0. So 75 minus 5x will equal 0, or 14,000 plus 800x can equal 0. So we solve each mini equation and we get our two roots of 15 and negative 17.5. But remember, we want to find our maximum revenue, so we want to find our h of our vertex. So we add our two roots and divide by 2, so we find that our axis of symmetry actually occurs at negative 1.25. So therefore that means that we're actually increasing the price 1.25 times. Okay, so because we had said by decreasing the price, we're actually, because it's a negative, we're going to increase the price. So what is the price that maximizes it? 75 minus 5 times negative 1.25, so $81.25 will be the price of a ticket in order to make the most money. Okay, so example 2, I've got another scenario. Find two positive consecutive even numbers whose product is 168. So I want you to try and come up with an equation first and then check back. Alright, so the key thing, find two positive consecutive even numbers. So they have to be positive numbers, they have to be one after the other, and they have to be even so that their product, so we multiply them, is 168. So if we let x be the first number, the next even number, so if we pick a number of 10, the next even number is 12, we added 2. So we can write that as x and x plus 2. So the product of x and x plus 2 equals 168. I want you to solve this equation by completing the square and then SAM-DEB. So pause the video before it goes any further and then come back when you're ready to check your work. Okay, so having expanded it and put it into standard form to then complete the square, you should have x squared plus 2x minus 168 equals 0. So you took the first two terms, you took half of the middle term, squared it, and that's what you added and subtracted. You then took the subtraction outside and then factored and simplified. So vertex form, we have x plus 1 minus 169 equals 0. You could go about solving this question from the standard form by doing factoring if possible, or also by doing quadratic formula. But I wanted to show you all three ways. Okay, so from vertex form, we're going to do SAM-DEB, so isolate for x. So we have to undo any addition and subtraction first. So we add the 169. We then get rid of any multiplication or division, which there is none. We then need to get rid of the exponent. So to get rid of the square, we take the square root of both sides. Remember, you're saying what number squared is a positive, so that could have been a negative. So the square root of 169 is plus or minus 13, because we could square negative 13 and get a positive 169. And on the left side, the square cancels with the square root, so you're just left with the bracket x plus 1. We then simplify the brackets by subtracting 1, and then we're doing negative 1 plus 13, which will give us 12, and negative 1 minus 13, which would give us negative 14. But remember our restriction that they had to be positive numbers, so therefore we can eliminate the negative 14, so only 12 is possible. So the two consecutive even numbers are 12 and 14. Okay, so the last method that we can use is by doing quadratic formula, and you tend to want to use that especially when you see decimals in your equation. So example 3, if a rocket is launched upward from an initial height of 3.4 meters at an initial velocity of 65 meters per second, when will the rocket hit the ground? Okay, so this is a scenario that's actually used in physics. Okay, so you'll see this when you do physics. Gravity on Earth is 9.8 seconds. So that would be our G value. And so when you do physics, it'll explain that the path of a projectile always follows this formula. Okay? So I'm going to go ahead and give you the values. So we have negative 1/2 9.8 t squared plus 65t plus the starting height of 3.4. And remember, you're being asked, when will it hit the ground? Well, what's the height when it hits the ground? Okay, so you're solving for t when the height equals 0. So we're going to use quadratic formula. So I want you to try and simplify this using quadratic formula and then come back and check your work. Alright, so having simplified this and found our a value of negative 4.9, our b value of 65, and our c value of 3.4, we can plug it into the quadratic formula and simplify. Okay, so we get down to the point of taking the square root and getting 64.49 when we round. So our two possible values are by adding and subtracting. So this is saying that it hits the ground at a negative time, which makes sense because remember, we started at an initial height of 3.4. So we were already above the ground. So we're only going to have one other time of when the rocket will hit the ground, and that will occur at 13.21 seconds. Alright, so this video has shown the three different methods: solving by factoring, solving from completing the square to vertex form to doing SAM-DEB, and then also by using the quadratic formula. Okay? So, if you want to get started on some of the problems, you can get started on page 311, and you can work on questions 1, 3, and 4, maybe even 6. But otherwise, just study for your quiz on using quadratic formula, and then we'll be working on word problems for the next few days. Okay?